Welcome back, students. Today is December the 2nd, Monday, and we did a lecture on graphing linear inequalities. We saw that in order to graph a linear inequality, it was the same procedure as graphing a linear equality. You have one of three methods you could select. Method number one, modified t-table. It is the longest method to use because you have to work the equation 5 times. Therefore, it's not the most preferred method. The x and y intercepts, this method works most of the time, unless you start getting weird-looking fractions. And the last method would be the slope-intercept form. This would be the preferred method to use, as it requires the least amount of work. And once you find the slope and the y-intercept, you are ready to go. So for this example, we're going to use the slope-intercept form. Well, you notice that the equation's already set because y has already been solved for. So what we're going to do is we're going to go ahead and isolate m and b. Well, for m, we have a negative 9/4 slope, and for b, we have a negative 5. As previously stated, if you're going to use the slope-intercept form, always start with b. b is the y-intercept. So we're going to make our first mark on this graph at b, negative 5. So we're going to start at the origin, go down 1, 2, 3, 4, 5, and this is where we're going to make our first dot. Let me make it a little bit bigger so we can see it. Now, the issue we have now is if you go back up to the slope, you'll notice that the slope is negative. Well, there's no way for us to go down 9 units on this graph, so we're going to use the reverse method. Instead of going down 9 units for the rise, we're going to go up 9 units. And instead of going right 4 units for the run, we're going to go left 4 units. So we come down and we count 9 units up. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we're going to go 4 units to the left. 1, 2, 3, 4, and right here would be our second dot. Well, that's sufficient. All we have to do now is to take our trusty ruler, connect the 2 dots, and with a steady hand, you'll notice that the comparison operator is to exclude. So we're going to do dashed lines instead of a solid line. Solid lines are only used for inclusion. So we're going to make our arrows on both sides where I can see them. And now it's just a matter of deciding what half plane to check or to shade. So for our half plane, we need to check the easiest point not on the line. So if we notice, this one seems to be the easiest point to check, 0, 0. So what we're going to do is we're going to use the ordered pair 0, 0 with our inequality y is greater than negative 9/4 x minus 5. And this time what we're going to do is replace the y with 0 and the x with 0. And now we just do our math. Nothing happens on the left side, you still get 0. And on the right side, this goes to 0, so you end up with negative 5. And obviously, this is a true statement. Since it's true everywhere on this side, so we shade this side of the graph. And now we have the half plane of all our solutions for this particular inequality. What does the half plane actually state? Well, the half plane actually states that I could pick any point I want on this side of the inequality, and my statement will always be true. Just to see how it works, if I were to take this ordered pair right here, which is obviously 3, 3, and I plug it into our equation, I get 3 is bigger than negative 9/4 times 3 minus 5. So here we go. We get 3 is greater than negative, let's see, that would be 27/4 minus, and I'm going to just change this into 20/4, and we get 3 is bigger than negative 47/4, which is obviously a true statement because all positive numbers are always greater than negative numbers. So this confirms we get a true statement. I hope this video helps. Next, I will be doing the in-class practice number 6, just so that you can see it fully worked out. See you in just a little bit.